Find the LCM of 12 and 15. So LCM, we can list the multiples of 12, then we list the multiples of 15. Then after we find the smallest but common. But I prefer using this method. Where we divide by prime factors which can divide any of these two numbers. So I start with 2. When I divide 12 by 2, I get a 6, but it can't divide 15, so I keep it. I can still divide by 2, I get a 3, but I can't divide that by a 2. Now I can't divide by 2 anymore, so I go to 3. So 3 divided by 3, you get 1, and this one you get a 5. And then we can divide by 3 anymore, we go to 5. This can be divided, I just write it the way it is. And then 5 divided by 5, you get 1. So when I multiply 2 times 2 times 3 times 5, I get my answer to be the LCM of 12 and 15. So our answer is 60. And then part B, it asks for the LCM of these 3 numbers. So again, we are going to use our method that you have 24 there. We have 30 and we have 45. I start dividing by a number which can divide any of those 3 numbers. So when I divide 24 by 2, I get 12. Here I get 15, and I can divide that, so I just keep it. Then divide by 2, I get a 6, I get 15, and I keep that. You keep the numbers which can't be divided by that number using at that time. So divide by 2 again, I get a 3, I keep 15, and I keep 45. So I can't divide by 2 anymore. So I go to 3, I get 1, and I divide 15 by 3, I get 5, and 45 by 3, I get 15. So the 3 can divide. Again, I use it. I get 1. It can divide 5, but it can divide 15 to get a 5. So, and finally, I use 5 to get 1, 1, 1. And then I have to multiply these numbers here. That is 2 times 2 times 2 times 3 times 3 times 5. So I'm having 2 times 2 times 2 is 8 times 9, and then times 5, which will give me 360. So that is our answer. That's why I prefer this method. Sometimes the LCM can be big, that when you start listing to get to that number, it will take a lot of time. And you have 3 numbers, so you have to list the LCM, the multiples of 24, multiples of 30, the multiples of 45 to such big numbers. So it's better use this method. Thank you.